Okay guys, so this is the 3.1 notes video for Colebank and Miss Nita's Honors Algebra 2 classes. We are currently in our matrices unit, and you had to watch the digital notes video and complete the digital notes for Intro to Matrices before watching this. So if you've not done that assignment yet, go and complete that, and then you're going to want to watch these notes because you have to know that information. I'm going to be going through this rather quickly because you can go through and you can pause as much as you need to. And then I'm also probably going to ask you to do a couple questions on your own. You'll just pause the video for that and then check your answers. So again, this is 3.1. We have actually 4 objectives for today because we have quite a few things we're going over. So the first objective is I can find dimensions of matrices and their elements. That's really just review from the digital lesson or the digital activity you did. I can add and subtract matrices. I can multiply a matrix by a scalar, and I can use matrix addition and subtraction to solve for variables. So again, we have a lot of objectives. This is kind of a big lesson. But none of the isolated skills are super tricky themselves. It's just we're doing a lot in one day. And here's the vocabulary for 3.1. So matrix is a set of numbers arranged in rows and columns so as to form a rectangular array. And an array is just like a shape. An element is a single term within a matrix. And then dimensions, which are also called order. So you could say what's the order of a matrix, but that's denoted as M and then the X, N, or we call that M by N. And it works as a lot of different dimensions work, where M is the number of rows and N is the number of columns. So in any given matrix, it's going to look like this. That's that rectangular array that was being talked about in one of the definitions. M is the number of rows, N is the number of columns, and you would have like elements within this matrix. So the dimensions would be M by N, so however many rows by however many columns. So again, as review from that digital lesson, but I do want to just go over this, some notation practice. So if I was given this matrix, we would call that matrix A, if I was ever referring to it. It has 2 rows, so that's going to be our M value, and it has 4 columns, so that would be our N value. And we can actually jump over, the dimension will be M by N, so 2 by 4. It's different from ordered pairs. You count down first and then you count over. Count down first and then you count over. I could also ask you to find elements, and the way we do that is you use the letter for the matrix, so it's matrix A, so I'd do a capital A, and then as a subscript, you would put 2 numbers, so A sub 2 comma 3. That is asking for the element in the second row in the 3rd column of matrix A. So if I go to the 2nd row, 3rd column, that element would be 7. So I could ask for A sub 1 4. I could ask for A 2 1. So go ahead, look at the matrix, try to find those 2 elements. So A element 1 4 is going to be the 1st row, 4th column. So that is going to be a value of 4. And then element 2 1 is going to be the 2nd row, the 1st column. So that is going to be a 5. So again, that is review from that digital lesson. If you didn't watch that digital lesson, go back and look at it because you need to know at least what a matrix is. You need to know how to find elements within a matrix, and you need to be able to find the dimensions of a matrix before you do anything else today. Now we're going to get into our first matrix operations, which are adding and subtracting matrices, or matrix addition and subtraction. There are a couple rules that go with this, and you need to know these. So addition and subtraction of matrices can only be done with matrices that have the same dimensions. It's kind of like with fractions. You can't add or subtract them if they have a different denominator. Well, with matrices, they have to have the same dimensions. It's the only way you're going to be able to add or subtract matrices. If your two matrices that you're trying to add or subtract have the same dimensions, all you do is you add and subtract corresponding matrix elements. And so the process for this actually isn't bad at all. So first you check that you have matrices that are the same dimensions, and then you can go through and add or subtract them. So here's what an example of this looks like. It says, example 1, perform the matrix operation. So this is matrix addition. I know that because I have a plus sign between two matrices. And I do want to find their dimensions to make sure that I can even do this operation. So the first matrix is 3 by 3. The second matrix is 3 by 3. So I know that I am good to do addition. You do have to check that, so make a habit of it. If they have different dimensions, you would just say that the sum is undefined. So now what we're going to do is we are going to make another matrix. And in this matrix, we are going to show the operation for each element. So my new element 1, 1 is going to be what I get when I add up -2 and -4. So it'll be -2 plus -4. Then I'm going to do the operation 0 plus 6, and that's going to go in position 1, 2. And then I would do 4 plus 0, and that is going to go in position 1, 3. So as you can see, all you're doing is you are adding up the elements that are in the same position, and then you're putting that sum in that same position on the new matrix. And then we can go through and do this for the second row. So I'm going to have 3 plus -15, -10 plus 2, -12 plus -4, and then hopefully you're getting the hang of it, 3 plus 6, -2 plus 7. I picked all orange in that middle column. That's kind of funny. And then -2 plus 1. Obviously, you're probably going to be able to start doing that in your head. I just wanted to show you the written out example. And then you will go through and you will simplify all of these. So -2 plus -4 gives me -6. 0 plus 6 gives me 6. 4 plus 0 gives me 4. 3 plus -15 gives me -12. -10 plus 2 gives me -8. 12 plus -4 gives me +8. 3 plus 6 gives me 9. -2 plus 7 gives me 5. And -2 plus 1 gives me -1. So that would be my final matrix. Your final matrix with addition and subtraction is the exact same size as your original matrices. So that is another thing that you can check, but that would be the final answer. So that was matrix addition. In example 2, we're going to practice some matrix subtraction. So basically the exact same process, but instead of adding the corresponding elements, you're just going to subtract them. You do want to check that your dimensions are the same. So these are both 2 by 2. So that works. Again, you have to check that every single time. And so when we write out my new matrix, we're just going to do subtraction with the elements that are in the same position. So you would have 2 minus -4, -18 minus 2, 20 minus -5, and -5 minus 1. Again, you don't necessarily have to show me this step, but if you skip it and then you mess up on your final matrix, I'm not going to be able to give you partial credit. So I suggest at least showing it. And then 2 minus negative 4, that's like 2 plus 4. So that'd give me, positive 6. Negative 18 minus 2 gives me negative 20. 20 minus negative 5, that's like 20 plus 5, so 25. And then negative 5 minus 1 gives me negative 6. So that would be the final answer on that subtraction problem. On example 3, we are doing matrix addition. So again, we have to check our dimensions. 2 by 2, 2 by 3 at O. Instead of being good to do addition, that is no good. And remember, we cannot do addition or subtraction if we have different dimensions. So we would just say undefined, because there is no way to find the sum in this example. And again, that is because you cannot add or subtract matrices that are different dimensions. So don't even try. Okay, so I'm gonna have you try example 4 on your own. You're gonna wanna pause the screen, go ahead, do subtraction. These do happen to both be 3 by 3. And you're doing subtraction, so make note of that sign. So go ahead, find the answer, and then I will tell you what the answer is. Okay, so this matrix, the final answer should have been negative 8, 6, negative 1, negative 12, 7, negative 6, 8, 11, 4. So again, you would do the corresponding subtraction to get all of those answers. The only one I could see maybe some trickiness on is minus negative 8. That's what gave you a positive 8. And then same thing, minus negative 10 gave you positive 11. Minus negative 4 gave you positive 4. So that last row is probably where I would expect any issues. But that's what your answer should be. Next, we're going to be moving on to what's called scalar multiplication. And there is just normal multiplication of matrices, but it's a lot harder. So we have to remember the difference between regular multiplication and scalar multiplication. Scalar multiplication happens when you multiply each entry in a matrix by a given scalar. And so if you look at this example down here, I'm given matrix A. It is a 2 by 2 matrix that is 3, 7, 9, 10. And then I am told I want to find 2 times A. So 2 is the scalar in this example. And basically, you are going to multiply every single thing inside matrix A by 2, and that is going to give you a new matrix. So you take every element, you multiply it by 2, and then once you simplify that, that is how you do scalar multiplication. So it's actually very similar to like distribution, but it's across a matrix. And a lot of you will be able to do this in your head. It might depend on what the scalar is. So say we did example number 5. It says find the following product, because again, we're doing scalar multiplication. Remember, that is different than matrix multiplication, which is what you're going to learn in 3.2. So if I was doing scalar multiplication, all I'm going to do is I'm going to take every element in the matrix and multiply it by negative 5. So I'd have negative 5 times 6, negative 5 times negative 7, negative 5 times 3, negative 5 times 8, negative 5 times negative 4, and negative 5 times 12, which would get me a final matrix of negative 30, 35, negative 15, negative 40, positive 20, and negative 60. So that would be that final product after scalar multiplication. So I'm going to give you 2 examples I want you to practice scalar multiplication on. So on example 6, there's actually like part A and part B. So go through and do these on your own, pause the video, and then I will tell you the answers afterwards. So some of you might have gone through and written out the work, and if you want to see the work, you can go look at the key. But on example A, I start out with a 1/3 matrix, so I'm going to end up with a 1/3 matrix, and I just multiplied every part by +8, so you would get 24, -72, and 136. And then on example B, I had a 3/3 matrix, so my product matrix is going to be 3/3, and I get it by multiplying every element by 6, so -18, +12, +6, 42, 48, and -30, 24, 36, and -54. So check your 9 elements in that matrix, and then hopefully you feel confident about scalar multiplication. Now, the last 3 examples we're doing are basically applications of the knowledge that we just practiced. So example 7, it says, given matrices A and B, show below, find -1/5 times A plus B. So this is a combination of scalar multiplication, which I'm going to do on matrix A, and addition of matrices. So first, let's go ahead and find -1/5 times matrix A. And we can just set this up. So we can do where'd it go? There we go. -1/5 times matrix A. So -5, -15, 10, 30, 20, -25. So I'll figure that out. And then I'm going to add matrix B to it if I'm allowed to. Okay, so I just went ahead and set up this problem. And now I'm going to go through and do the scalar multiplication first, and then if possible, I will add the matrices together. So when you do a scalar multiple of -1/5, it ends up like you're dividing each of those elements by -5. So when I go through and do that, the scalar multiplied version of matrix A is going to be +1, +3, -2, -6, -4, and +5. And then I'm going to try and add that to matrix B. Again, you cannot add or subtract matrices until you know they have the same dimensions, and these have the same dimensions, so I will be good to do that addition. So your final matrix is what you get when you add up the corresponding elements. So 1 + 4 would give me 5. 3 + 5 would give me 8. -2 + -7 would give me -9. -6 + 7 gives me 1. -4 + 0 gives me -4. And 5 + -5 would give me 0. So that would be that final matrix. Again, it's an application of scalar multiplication and addition. And it works like order of operations. You would do multiplication first, you would do addition second. Okay, 2 more examples. We're going to apply what we know. So it says, use what you know about matrices to solve for the missing values. So if we look here, I have 2 2x2 matrices. This one's 2x2, this one's 2x2, and they're set equal to each other. So what's cool about that is what we can do is realize that the elements that are in the same position would have to be equal. So 0.5 equals 0.5, that makes sense. 4 equals 4, that makes sense. So we can set the corresponding elements equal to each other, and that will allow us to solve for y and to solve for x. So I can set -3y equal to 3. And if I divide both sides by -3, I get that y equals -1. So again, because I have 2 matrices that have the same dimensions set equal to each other, their corresponding elements will be equal to each other. And then I can do that with the x variable as well. So 0.5x has to equal 5. And if I divide both sides by 1/2, I get that x equals 10. It's like multiplying by the reciprocal when you divide by a decimal. So x would equal 10. So that would be one way that I could test whether you understand how matrices kind of operate with each other, that the corresponding elements would be equal if the matrices are equal. I could also give you an example like this, which is a bit more challenging. So in this example, I have two matrices that are being added together, and then they equal a third matrix. All of these matrices are 2 by 2, so the matrix operations would pan out. And so what I'm going to do here is focus on the different elements again. So 7 plus 3 equals 10. That works. -4 plus 13 equals 9. So that works. That means I could do 5x plus y equals 13. And then I could also do 2x plus y equals 7. Again, we're trying to solve for the missing variables, but instead of getting the values of the variables immediately, what I've done is I've had you guys set up a system of linear equations. So we can solve a system of linear equations using substitution or elimination, which is how I want you to finish up this problem. So because I have two y values that have a coefficient of 1, I'm going to do elimination. And I'm going to get opposite coefficients by multiplying that second equation by -1. So I get 5x plus y equals 13, -2x minus y equals -7. And then I can do elimination by adding down. So I get that 3x equals 6. Divide both sides by 3, you get that x equals 2, and you're halfway to your solution because, again, you're trying to find both variables. So then I can plug in x equals 2 here, 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 or here to figure out what y would equal. I'm probably going to put it in 2x plus y equals 7. So 2 times 2 plus y equals 7. 4 plus y equals 7. So y equals +3. So the ordered pair 2, 3 would be the solution to this system, which is also the solution to this matrix addition problem. So as you can see, once you know a couple basic matrix operations, I can then give you a lot more interesting questions that make you apply those skills. So that is going to be the lesson for 3.1. Go ahead, take a look at these objectives. Make sure you feel like you can do all of them. And then you're going to go work on your homework packet. See you later.